Y'all are good.
Alright, our topic was on the calculus in football. I'm Carter Kiki.
And I'm Hunter Farner.
The topic questions we wanted to ask were the instantaneous rate at the time of a collision in football, so when a player is tackled. We wanted to see how it affected their velocity, why the instantaneous rate is what it is through impact force, and how we could use calculus to find the volume of football.
So the first thing we took a look at was how we relate this to our lives, and we have two videos of both of us getting rocked. We'll start with mine. I did get knocked out here, and yeah, I'm right here, right there. I'm done. And as you see, Cutter just walks right past me there. But yeah, that's one of them. And then we have one of Carter here. He's right here right now.
Chasing down the interception. And
Right there.
right there, and
just
laid out.
yeah. Don't worry, we both somehow survived.
Mm-hmm.
I'm still living. We got the. Oh, wait a minute. And then this is the video we actually want to take a look at. We could have used ours, but the quality, A, wasn't as good, and it would have been kind of embarrassing to find out our velocities. So, he's somewhere, we use this one right here. Oh. So we wanted to find their velocities and like stuff with that. So we started by finding the instantaneous rates. Okay. You can't really see the graph, wait, once this goes away you will. But we made it using a position time graph, and by finding the derivative that we were able to find that like the velocities were negative 4.34 yards per second, and his velocity was 2.849 yards per second. This was found after the catch, and you can see his velocity was a lot slower than his, is probably why he got knocked out. And then here are the equations of them. And we looked at it as a constant of velocity, that's why we have the acceleration of 0. But right here is the position of Brandon Cooks to caught the ball after the catch, so we looked at it as a 0. And we looked at Tedrick's as a negative velocity, because he's coming this way. And this will be his velocity here, and again 0 because we looked at it as a constant. So we converted everything, or before this, we had it all in yards per second, but we used a conversion online to move it to meters per second because that's a more general unit for calculus and physics. So the change in velocities after the hit, we used this equation right here, which states that the mass times velocity plus the mass times velocity of both of them is equal to the mass, their two masses combined times their velocity after. So we just had to plug their velocities in and the masses in, and the masses over here, and we were able to find the velocity of them after the hit. And we found that these were their masses. We used that by looking on like NFL.com. And then these are the velocities we calculated earlier. And then before the hit, he was going 2.560 meters per second. And then after the hit, he was going 0.848 meters per second, negative. And we found that the change in velocity during the hit was 3.453 meters per second in the negative direction. So the impact forces of each, we found this equation online, and this just kind of gives us a better scale to see how much force went into each of the players' hits. So we found their mass like we had before, the velocity is the same, and the distance. We found that Tedrick traveled 3 yards in the time it took him to travel 2, so his distance was a little greater than his. And we found that he had a force of 258 newtons, and he had a force of 148 newtons. That's probably why they moved in the negative direction.
So the next thing we wanted to find out was the volume of an NFL football. So to find it, an NFL football is a prolate spheroid. We can use an equation of an ellipse and the disk method to find that volume. But first we need the dimensions of the ball in order to create the equation of the ellipse. So in researching, the official dimensions of the NFL football is from tip to tip, the length is 11.25 inches, and the only other measurement it gives is that at the very center of the ball, the circumference around is 22 inches. And And the general equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. And we can use those dimensions to find a and b. So using the dimensions, since the major axis is 11.25, half of it would be a, which is 5.625 inches. And then using circumference and the equation for the perimeter of a circle, we found that the minor axis would be b, which is equal to 3.501 inches. Then using those, we can plug it into the equation of an ellipse. And then I solved for y to make it a little easier to do the disk method. And for an ellipse, when it's solved for y, you get a plus or minus of a square root. It gives a top half of the ellipse and a bottom half. And so when we were going to use the ellipse, we only wanted the top half, so we're only going to use the positive equation. These are the graphs. See how it has a positive curve and a negative curve, and how we're only going to use this positive curve and we're going to rotate it about the x-axis. And then by doing so, using the disk method, only rotating it about the x-axis, we got a volume of about 288.799 inches cubed for the volume of an NFL football.
That is the end. And rephrase the slide here. Any questions?